Hello, good day everyone. In this portion of the video, we will be talking about the first part of the fundamentals of mathematics for business, and that is fractions, decimals, and percentage. Let me start the presentation. Our objective for this topic is to demonstrate understanding of fractions, decimals, and percent. Perform addition, subtraction, multiplication, and division of fractions, decimals accurately. And lastly, to solve business problems involving fractions, decimals, and percent. Starting with decimals. By definition, decimals are numbers with decimal point and decimal places and can also be defined as a fraction with unwritten denominator of 10 or some power of 10. An example of a decimal is this one. We say 0, we say for a moment. We say that okay, let's say 0.2, what else? 2.1, 5.5. These are examples of decimals, okay? So, to write it clearly, we have, for example, another 1.5. We also have 3.6, 7.8, and we also have 0.0, 0.00001. These are just examples of decimals. Now, let's move on to adding decimals. An example here which illustrates the number 0.32 plus 12.965 plus 1.1. And how are we going to add these decimals here? In that case, we need to line up first the decimal points, which means we are going to align the decimal points in this manner. As you can see, there is 0.32 is just equal to 0.320. And then on our second example, we have 12.965, and then we align the decimal point together, and the third one, which is 1.1, and next we need to pad with zeros. As you can see there, the colored blue, we are writing zeros there for us not to be confused to what we are adding. Okay, and with that, we are ready to solve we are now ready to solve the following. In this case, we need to start from right going to left. Okay, so starting with this, followed by this, this one, and lastly that one. Okay, 0 plus 5 plus 0 is equal to 5. 2 plus 6 plus 0 is equal to 8. 3 plus 9 plus 1 is equal to 13, which means we need to bring down 3, carry 1. So there is an imaginary 1 here. So that's 1 plus 2 plus 1, which is 4. And then lastly, we bring down 1. If you want to confirm the answer, you can use your calculator after solving this, which will have the same answer, which is 14.385. And for we have another example here, the number 51 plus 14.02 plus 2.1. In that case, we are going to apply it the same way. We line up the decimal points, but looking at the whole number here, we have a 51. We change whole number to decimal. It's very easy. Just simply add 0.00 and then that whole number will become a decimal value. From 51, it becomes 51.00. So we can now consider this one as a decimal value because of the 0.00. And with that, we are ready to solve the following. We write first 51.00 followed by 14.02 and by 2.1. And we pad the 0 here with our 2.1. And as you can see there, we aligned our decimal points as always. Then we are ready to add 0 plus 2 plus 0, that is equal to 2. 0 plus 0 plus 1, that's equal to 1. 1 plus 4 plus 2 is equal to 7. 5 plus 1 is equal to 6. Therefore, the answer here is 67.12. Now let's have example 1.1. Let us read and answer this problem. You deposited 15,000 pesos in your savings account that has an available balance of 185 and 455,000.43 pesos. Your deposit earned the following interest: 61.67 pesos in December, 318.70 pesos in January, 180.16 pesos in February, and 212.12 in March. What will be your savings account available balance? In this case, we need to situate our problem our problem well. Therefore, let me underline the following given. We have 15,000. We have 185 and 185,455 pesos, 0.43. We also have the interest. Okay, these numbers will be part of our solution set for this problem. Okay, from the word itself, deposited, which means we added to our savings account the following value, which is 15,000. And with that, we also earned the following interest from the value we deposited. And that is the following: 61.67, 318.70, 180.16, and 212.12. So these are interests from the value we deposited. And now we are ready to solve. What will be our what will be your savings account available balance? Let's proceed to the solution part. Let me clear this one. Here we go. We need to state first the following given, okay? Remember that we have 185 and 185,455.43 on our savings account. And we deposited 15,000. So we are going to write it like this. We align the decimal point. 15,000 is just the same with this value. I just added 0.00 to make it a decimal value. Next, we have an interest. We earned an interest from the value we deposited from the bank, which means we are going to add all the interest together. And that's 61.67 for the first interest. We have 318.70. We also have 180.16, and lastly 212.12. Okay, So let us recall that this is our balance, and this one is the value we deposit, and then the four of these are the interest earned. Interest earned. Okay. Now, in this case, we will be adding everything, okay? From our balance to the value we deposited and to the interest we earned from the bank to solve for the remaining to solve for our savings, for the balance of our savings account. This is also the basic concept of adding numbers starting from right going to the left. Therefore, we have 3 plus 7 plus 6 plus 2, that's equal to 18. So we bring down 8. Okay, let me carry 1. So this is I'm gonna write it there for you to visualize. And then we add 4 plus 1 plus 6 plus 7 plus 1 plus 1, and that's 20. So I'll be writing there 0 and then 2 here above. Don't forget to write the decimal point. And now we're ready to add 2 plus 5, that's 7, plus 1, that's 8, plus 8, 16, plus 2, that's 18. So we write down 8 and then 1 above for us to visualize the value 1. 5 plus 1, that's 6, plus 6, we get 12, plus 1, we get 13, plus 8, we got 21, plus 1, we got 22. So we write down there 2, bring down 2, and then 2 above. So there's going to be 2 above 4. So that's 2 plus 4 plus 3 plus 1 and plus 2, and that's equal to 12. So let me write down here 12 and 1 here. 5 plus 1, 6 plus 5, that is 11. So we write here 1. 8 plus 1, that is 11. So we have 1 here. 8 plus 1, 9 plus 1, that's 10. We write 0 and then 1 here. And 1 plus 1 is equal to 2. Therefore, our total savings, the balance of our savings will be 201,228.08 pesos. So don't forget the peso sign since this is a problem solving. We need to write the peso sign, okay? And that's how we solve for our example 1.1. Okay, let's move on. Wait a minute. Where is it? Here we go. Okay, next. Subtracting decimals. So here we have one example below how to subtract decimals. Okay, so let me give you the details. Given 13.8 subtract minus 1.27, that means we are going to subtract 1.27 from 13.8. And now we align or we line up the decimal points. So that's 13.8 and then negative or 1, negative 1.27. We align there the decimal points. Look at that carefully. And then we pad with 0. So which means we add 0 from 13.8. It will become 13.80. Don't worry, they are just the same. Now we are ready to subtract. This the process will be from right to left, okay? Subtracting from right to left, we have 0 minus 7. That's not possible, which means we're going to borrow from the left of 0, which is 8. So 8 will become 7. So let me give an annotate here. Let's have another color because there's a red there. This one. Okay, so you can see 8. Oh, that's not clear. Let's have this. 8 will become 7. And then 0 will become 10. So we are now ready to subtract. 10 minus 7, we got 3. So you can see that. Next, 7 minus 2, we have 5. 3 minus 1, that's 2. 1 minus 0, that's 1. Therefore, our answer is 12.53 for this example. And that explains why is that the answer. Let's try to answer a problem. We have here example 1.2. Your business needed an additional capital of 150,000 pesos, which you planned to withdraw from your savings account. If you have 231,452.49 pesos in your account, and you know that the withholding tax will be 71.07 pesos, how much will be left in your savings account? First, let us situate the problem. In this case, the problem mentioned needing an additional capital, which means you need a capital. It may be a business, right? You might be running a business, so you need a capital for that business, for example. And the capital is worth 150,000. So you can see this one, 150,000. And then you need to withdraw a value, the same value from your savings account. So you have an amount of 231,452.49 from your savings account. Okay, so we're gonna withdraw 150, which means we're gonna subtract 150 from our savings account. Together with the withholding tax, which is 71.07. So we're going to subtract another value, 71.07, from our savings account for us to know how much will be left in your savings account. Okay, which means that's savings account minus 150 and then minus 71.07. So let's do that in our solution. Here we go. So the first things first, we are going to present the savings account minus the capital that you will be needing, which means that's 231,452, if I could recall, 0.49 subtracted, or we are going to subtract 150,000 from that value, and it's very simple. Subtract, that's 9 4, and then the decimal point. After that, 2 minus 0 is 2, 5 minus 0 is 5, 4 minus 0 is 4, 1 minus 0 is 1, and then 3 minus 5, we cannot operate that first, so we're gonna borrow from 2. We're gonna have 13 and 1 here. 13 minus 5 will be 8, and 1 minus 1 is 0, so no need for us to write 0, which means we have a remaining amount of 81 and 452,000.49 in our savings account. But we have a withholding tax, okay? We need to subtract another value, which is the withholding tax, 71.07, for us to know the remaining balance of our savings account. So that's 9 minus 7, 2. 4 minus 0 is 4. Don't forget the decimal point. 2 minus 1 is 1. 5 minus 7, we're gonna borrow from the left of 5 because we cannot subtract 5 minus 7. Therefore, this left portion will become 3 and 5 will become 15. 15 minus 7, that's 8. Then 3 minus 0 is 3. You bring down the following numbers since we don't have value now here. It's already 0, 0, 0. And we are ready to say that the remaining balance of our savings account will be 81,381.42 pesos. That's the answer for the problem, for the second problem. Now let's move on. Multiplying decimals. We are going to follow this guided step here. First things first, how are we gonna multiply? We multiply like whole numbers. We count decimal places in the problem and then put the same number of places behind the decimal in the product. For example, you have the value 2.34 times 1.2. And as we do the multiplication, 2 times 4, 8, 2 times, we do it one by one, 2 times 3, it was not shown there. So let me show it to you here, the detailed one, for you to clearly understand how we got that answer. So that's 2.34 times 1.2. So we don't need to align the decimal point for multiplying decimals. Okay, so 2 times 4, that's 8. 2 times 3, that's 6. 2 times 2, that's 4. Then 1 times 4 is 4. 1 times 3 is 3. 1 times 2 is 2. And we add. That's 8. That's 10. 7. That's 8. And then 2. So this is the detailed solution on how we get the value 2.808. The question there, in our product, why does the decimal point become 3? Okay, it's because we count the decimal places in the problem, which is 0.34. So we count that 1, 2 decimal places, and then 1.2 has 1 decimal places, and then altogether 1, 2, 3. That's 3 decimal places all in all. So as you can see there, the label 2 decimal places plus 1 decimal place is equal to 3 decimal places. And that's how we are going to multiply decimals. Let's try it on a problem. Example 1.3. K is an event organizer. She is organizing a kiddie birthday party for 150 guests. She purchased 150 party hats from a party item supplier at the amount of 5.99 pesos each. If her quoted price for the party hat is 10 pesos each, how much would her profit be? We're talking about the profit here, which means what should be the value that she is gonna receive. Okay, let's situate the problem first. She will purchase 150 party hats from a party item supplier at the amount of 5.99 pesos, which means you're gonna visualize we will be multiplying the amount 5.99 to 150. But there is another statement here. If her quoted price for the party hat is 10 pesos, so which means she has the value 10 pesos for the hat, but from her supplier she's gonna buy it for only 5.99, right? So there will be a profit for that one. So we are going to multiply 150 by 5.99 and also multiply 150 by 10, and let us subtract the answers of those. Let us subtract both answers. Okay, let's proceed with our solution. Okay, looking at this point, we are going to multiply first our supplier value. Wait a minute. 99. Wait, let me write it here in the middle part. So we could have more space for the multiplication solution. So we have it here, 150 multiplied by 5.99. So that's a multiplication. So we do it one by one. So we're gonna have 0, 5, and there's 4 here. 4, 9 times 1 plus 4, that's 13. And then the same, 0, 5, 3, 1. And then for 5, that's 0, 5. 5 times 5, 20. 5 times 5 is 25, so there is going to be a value 2 here. 5 times 1 is 5 plus 2, that's 7. And then we add 0, 5, 8, 9, and then that's 8. And then we count the decimal point, that's 1, 2. So we're going to write here. So our value will be 898.50. That is for the original price, which is 5.99. How about for the quoted price? That's 150 times 10, which means that's gonna be, we're gonna write there 0, 0, 0, and this is 0, 5, 1. And as we add that, that's 1,500. And to solve for our profit, we're gonna subtract 898.50 from 1,500. That's 15 minus 898.50. So it's gonna be 0, 0 here. Okay, now let's subtract 0 and 0. We got 0. We need to borrow from the numbers from the left, which means this will become 10, this will become 9, and this will become 9, and this will become 4, because we cannot borrow from 0 alone, right? So we're gonna borrow here, so it's 10 become 9, 10 become 9, and then 0 becomes 10. Therefore, we write there 5. Next, 9 minus 8, that's 1. 9 minus 9, it's 0. And then 14 minus 8, that's 6. Therefore, our profit, or the profit from that problem, will be 601.50 pesos. That's really a big profit, right? Buying the given a quoted 10 pesos for each hat, and then you're buying each hat for an original price, which is 5.99. That's really a big profit if you are the organizer of that problem. That's really big. So that's the answer. Moving on, dividing decimals. Okay, so here is a process in this portion. So let me explain the process. Okay, given 3.64 divided by 1.4, 3.64 is our dividend, 1.4 is our divisor. And first things first, we make the divisor a whole number by moving the decimal point, which means 1.4, we move it to the right, one place to the right, so that will turn to 14. And move the decimal point in the dividend the same number of places. So if we move 1 point here, we also move 1 point there. So 3.64 will become 36.4. Okay, so I hope you're following the process. After that, we are ready to divide. So we divide 36.4 divided by 14. So we start with the first 2 digits, because 14 is 2 digit. We divide it by 2 digits also. So 36 divided by 14, that is 2. And then we follow the process. 2 times 14 is equal to 28. After that, we subtract 36 minus 28. That's equal to 8. And after that, we cannot divide 8 by 14. That's why we need to bring down 4 here. And we have now two values, which is 8 and 4. Now we can divide it by 14. 84 divided by 14 is equal to 6. The question there is, why did we write point there? Because it's already it it's already belong. Yeah, I mean it belongs to the line or to the point, decimal point of our given. Remember that we have here 36.4. Therefore, we also point there to 0.6 because it's already the point 4 being, we bring down point 4 already. Okay, so I hope you get that point. We bring down a point 4 already, so we write also there 0.6, and we multiply 6 times 14, we get 84, and as we subtract, that's equal to 0. And then for the last step, we line up the decimal point in the quotient with the decimal point in the dividend. So we just line it up, okay? Like this. Therefore, the answer is 2.6. 2.6. So that's how the process goes. Now, let's try to solve problems which is related to dividing of decimal values. Let's read and answer the following. We have a sari-sari store ordered 4 trays of medium-sized eggs at a wholesale price of 125 pesos each tray. If each tray contains 2.5 dozen eggs, how much is the cost of each egg? Okay, let's situate the problem first. In this case, we are going to disregard 4 there because the problem asks how much is the cost of each eggs. So we need to stick with the number of eggs, which is 2.5 dozen, and then the price of the wholesale, a wholesale price of 125 each tray. So these values here, 125 and then 2.5 dozen eggs, will be our important values for our solution. Now let's move on to our solution part. Okay, let us recall first the concept of dozen. Take note that, so let me write here, note that 1 dozen is equal to 12. And therefore, in our given, we have 2.5 dozen, and that's equal to 30 because 12 times 2, 24, and then a half of 12 is 6. 24 plus 6, it's 30. So we are going to multiply 125 pesos, which is the value of the wholesale for each tray, 125.00 divided by, it's going to be divided by 30. We cannot divide 12 by 30, so we proceed with the 3 digits. 125 divided by 30, that's 4, because 4 times 30 is 120. So we have, as we subtract, we follow the process. That's 5 here, and we bring down. We bring down 0. So we're gonna write point here because we move on to the decimal place already. So 50 divided by 30, that's 1. 1 times 30, that is 30. 50 minus 30, that's equal to 20. We cannot divide 20 by 30. We bring down 0 again. Therefore, 200 divided by 30, that's equal to 6. Yeah, 6 is the closest one. 6 times 30, it's equal to 180. And as we subtract, that's 20 again. And as we move on, so we can still add 0 here because that they're just still equal with 125, even though you're gonna add more 0 there on the right side of your decimal place. So we're gonna bring down 0 again, and we can also have the same answer, which is 1.66, and that's 180, and that's 20. And the process keeps on repeating, okay? Which means we can now have an approximate value of approximately 4.6 4.167. So that will be the price value for each egg. Okay, so each egg is approximately 4.167 pesos. Okay, so that's our answer for that problem, applying the division of decimals. Now, let's have fraction. Okay, so the definition of fraction represents a part of a whole or a group. It is expressed as a quotient of two quantities, namely the numerator and the denominator. With that, an example of fraction is 1/2. We also have 3/4. We also have 5 over 2, that is still a fraction. We also have 10 over 3, that is still a fraction. And then 1, 3, 5, 10 are the values we call numerator. So these are the numerator. These are the numerators, and then 2, 4, 2, and 3, we call them denominators. Okay, so this is just a recall of our basic concept of how we identify fraction. But fraction has three kinds. We have proper fraction, improper fraction, and mixed fraction. An example for proper fraction is 1/2. We also have 2/3. Improper, we say 5/4. We have 10 over 7. We also have 20 over 6. So these are examples of improper fraction. For mixed numbers, so it is a mixture. So we have 1 and 1/2. We have 3 and 1/4. We have, let's say, 10 and 2/3. So these are examples of mixed number. By definition, looking at our example, we say that a proper fraction is a fraction whose numerator is less than the denominator. We're talking about the value. The value of our numerator here is less than the denominator. Okay, look at our example again. 1 is less than 2, and then 2 is less than 3. So that's how we define it. For improper, so this is the opposite way. Numerator is greater than. Numerator is greater than our denominator. Okay. And then for the mixed number, so just simply looking at it, it is a mixture of whole number and a fraction and a proper fraction. So that's how we define the kinds of fractions, okay? Please take note the following definitions and examples. With that, let's move on to adding fractions. We have a step here on how are we going to add a fraction. First, adding fractions with like denominators, which means denominators are the same. We have 1 over 7 plus 3 over 7. As we add them, we add the numerators, which is 1 and 3, so that's 1 plus 3. After that, denominators is unchanged. We are not going to change, we're not going to add the denominators, but remain it as it is. So for the answer, we have 4 over 7. Okay, so if you're looking for another example, same goes for an example like this. If we have 1/2 plus, let's say 3 over 2, as we add that, the answer is 4 over 2. In this case, we can still simplify. The answer there is 2, right? And another example, if we have 7 over 3 plus 8 over 3, then that is 15 over 3. We can still simplify that. That's equal to 5. Okay? So take note, if a fraction can be simplified, we simplify our final answer. Okay? But there are cases that the answers cannot be simplified, so we don't need to simplify that and remain it as it is. Okay? Now, fractions with unlike denominators. How are we gonna do that? 1 over 8 plus 2 over 3 as our example. In that case, we are going to apply the solving for the LCD, which is the least common denominator, and then we are ready to solve and to add them if we already have our least common denominator. So in this case, this process, it mentioned rewrite the common denominator. So let me write it here, or we can also do it like this. Least common denominators will be factors of 8, which is also divisible by 3. So the least value will be 24, because 24 is also a factor of 8, and at the same time, it's the least factor of 3 also, which is the least factor of the two. We can also say 8 times 3 is 24. They're just the same. And in that case, we are ready to solve for our given. So as you can see here, we can now add the numerators if we're doing this kind of process. Okay, so this is a different process. But looking at my process, we can also do it like this. 4 divided by 8, and after that, after you divide it by 8, you're gonna times it times your numerator. So 24 divided by 8, that's 3 times 1, 3. After that, plus 24 divided by 3 times 2, that is 8 times 2, 16. Therefore, 3 plus 16 is 19. That's equal to 19 over 24. You can also do this process. You can also do this process on the box. We will get the same answer, which is 19 over 24. Okay, so you have two process of solving, adding fractions with unlike denominators. Please take note for that. Now let's move on to example 1.5. Let me read it for you. You were given a task to prepare 3 kinds of desserts for the marketing week. Based on the recipe, you will need 2 and 1/3 cups of flour for the pie, 1 and 3/4 cups of flour for the cookies, and 1.1 cups of flour for the cake. How much flour do you need to make the 3 desserts? Which means we are going to add everything, which is this one, and this one. So let's do that in our solution. So adding the following, we have 2 and 1/3 cups. So we have it here, 2 and 1/3 plus 1 and 3/4 plus 1 and 1/2. Okay, that's how the given state the following. With that, first thing to do is to convert. We need to convert it. Okay, take note. We convert. Okay, this is VERT. Convert mix to improper fraction. So that's the first thing to do, okay? So now let's convert. 3, as you convert, the process goes like this. 3 times 2 plus 1. So it's multiplication here and then plus the numerator, okay? 3 times 2 and then plus the numerator. And then we are going to follow the same denominator. 3 times 2, 6 plus 1, that's 7 over 3. Plus 4 times 1, 4. Plus 3, that's 7 over 4. After that, plus 2 times 1 is 2 plus 1, that's 3 over 2. We are ready to solve the following. With that, let's solve first or look for the LCD of the 3, which means the common denominator of 3, 4, and 2. And the least common denominator for that, I think it's very easy. It is 12. Why? 12 is the nearest number, which is divisible by 3. The least number or the smallest number, which is divisible by 3, 4, and 2. Now we are ready to proceed. So 3, let's follow my step. So I'm gonna divide it by the denominator and then multiply it by our numerator. Okay? With that, we have 12 divided by 3. That is 4 times 7. We write here 28 plus 12 divided by 4. That's 3 times 7. We write there 21 plus 12 divided by 2. That is 6 times 3. We write there 18. Now we add the following numerators. That's 28 plus 21 plus 18. That's equal to 67 over 12. Or you could simply write 5 and I think 7 over 12. Okay, you can also confirm if that's correct. So either of the two answers are correct. Okay, so we're gonna need 5 and 7 over 2 cups of flour. Okay, so cups is already okay. If you want to complete it, you can have 5 and 5 and 7 over 12 of cups of flour for the answer. Now let's have the subtraction. Subtracting mixed number. Okay, so we have here method 1, method 2, method 3. Either of the 3 process or 3 methods, you will get the same answer. Okay, but if I were to choose in subtracting mixed number, I'd rather choose converting it first to improper, which is the third one. If you're asking why, for me it's easier to do it like this because the process is very clean. But if you are comfortable with things like this, we subtract 3 minus 2 and 1/2 and then plus the 33 over 5. I think it's quite complicated in method number 1. Method number 2 is also okay because we subtract first the whole number 3 and 2 plus the subtraction of our fraction which is 3 over 5 minus 1/2. You could also do that. Okay? And in my case, I'd like to use method number 3 because we convert it first to improper. From mixed number, convert it to improper. And then we move on by solving the LCD and then the process of, and then follow the process, I mean. So whichever method you wanted to use, it's really okay for me. That is not a problem. So if you want to take a screenshot for this one, please do. But if you want to stick with one method, that's also okay for you to have a uniform way of solving a certain process. Now let's try answering example problem 1.6. So we have it here. A job order takes 4 1/3 hour to finish. If a worker has been working on it for 2.5 hours, how much longer should the customer wait to get his job order done? In this case, we need to situate first the problem. So a job order takes this hour, but a worker has been working, which means they've been working for 2.5 hours. The question there is how much longer should the customer wait, which means we are going to apply subtraction here. Okay, simply subtracting 2.5 hours from 4 1/3 hours. Okay, let me show you here. In this case, we have this one, 4 1/3 minus 2 1/2. Okay, if I could recall, I think that's the correct given. So as we subtract that one, in my case, I'm gonna convert it first. So I'm gonna put a bullet convert. Convert mix to improper. Okay, so this will become 13 over 3 minus, this is 2 times 2, 4, plus 1, that's going to be 5 over 2. Okay, after that, we look for the LCD. Okay, our LCD here, this is going to be LCD. 3 and 2 will be 6. Okay, we will have an LCD 6, so which means this is equal to 6 divided by 3, that's 2. 2, and after that 2 times 13, we will get there uh 26, right? After that, minus 6 divided by 2, that is equal to 3. 3 times 15, okay? 3 times 5, that's 15. Okay, sorry for that. And then we subtract 26 minus 15, that's equal to 11 over 6. And that is our answer. 11 over 6 hour. Or you could write, or that's 11 divided by 6. That's 1. And how do you say that one in mixed number? 1 and 5 over 6. Right? So you write there hour. Or you could have the different way, which is 4 minus 2 plus 1/3 minus 1/2. Okay, that's this is method number 2. So we're gonna have 2 2 plus, so what's the answer here? It's gonna be over 6 6, and then 6 divided by 3, you will get 2, and then 6 divided by 2, that's 3 times 1, so it's gonna be a minus. Okay, 6 divided by 2, 3 times 1, so this is 3, right? After that, that's 2 plus negative 1 over 6, right? As you can see, this is quite complicated because this is a fraction and a whole number. And when you add that, you need to convert it first into a fraction, which means it will become 12 over 6 minus 1 over 6. So you will get 11 over 6. As you can see, this becomes complicated, but you will still get the same answer, which is 11 over 6 or 1 and 5 over 6 hour. Right? You could compare which one is better for this case. Okay? That's the answer for that example 1.6, problem 1.6. Now let's have multiplying fractions. How do we multiply fractions? First things first is to multiply the numerators. Okay, in this given we have, let me illustrate. Numerator multiplied by the numerator, so that's 6. Next is multiply the denominators. 5 times 4, that's 20. And after that, you get the answer 6 over 20. And take note that we reduce the fraction if necessary. So 6 over 20 is reducible, and that the reduced answer or the simplified answer is 3 over 10. So that's the 3 process to consider of multiplying fractions. Next, let's have the steps, okay? So it gives here 5 steps to consider. First, change the mixed number if any. If there is a mixed number, we need to change it to an improper fraction first. After that, Before multiplying, cross cancel to reduce the fraction. Okay, this is optional. If you don't want to cross cancel, it's okay. You can proceed to multiplication directly if you are not familiar with cross multiplication or cross canceling. That is cross canceling, I mean. Third one is multiply the numerators and also denominators. Fourth, convert the results, if improper, to mixed number. So we convert the improper to mixed. And lastly, reduce your answer in its simplest term. Okay, so this is the last one. Again, if you're not familiar with cross canceling, it's okay. You could proceed with the third step. Now let's answer example 1.7. Your bake shop received an order for 2 cakes. A recipe for a cake specifies 3 1/4 cups of cake flour and 3/4 cup butter. How much flour should you buy? How much butter? Which means the combination of two. How much flour and then how much butter? So which means 2 cakes, which we're gonna have 3 1/4 cups of cake and then 2 3/4 cup of butter. So we just simply multiply it by 2. So let's start with let's start with the flour followed by the butter here in our solution. Starting with the flour, we have 3 1/4. Wait a minute. Okay, here we go. Okay. Oh, I got the wrong one. Okay, let me erase and let me choose the pen and here. Let's start with the flour. So here, in this case, here is the flour and here is the butter. So to separate our solution. For the flour, we need 4 1/3, right? 4 1/3 times 2. And for butter, we need 3/4 times 2 because we need it's for good for 2 cakes, right? And with that, we change it first to an improper. So first things first, convert 4 1/3 to improper. Okay, as we convert that one, 3 times 4, 12 plus 1, that's 13/3 times 2. So in this case, 2/1 or 2 are just equal. We are ready to multiply that. 13 times 2 is 26/3. So that's for our flour, okay? And do you think it is reducible? 26/3 reducible? What do you think? It is not reducible, which means we are going to express this one into mixed number. Okay, this is gonna be equal to 8 and 2/3 because 26 divided by 3, 8 is the nearest one, right? And then 2/3, 8 2/3 cups of flour. Okay, of flour. Okay, let's move on to butter. 3/4 is already a fraction, right? So just simply multiply it directly. We will get 6/4. And 6/4 is reducible, so it is reducible by 2. 3/2, or into a mixed number, that's 1 1/2 cups of butter. Okay, so that's our answer for that problem 1.7. Now, dividing fractions. For dividing fractions, we need to follow these steps. First, invert the fraction that you are dividing by, which means we're gonna invert or the reciprocal of the 2/3. Wait a minute. Here's the laser. Okay. So if this is our dividend, we need to find the reciprocal of our divisor. So, or invert, which means inverting this expression, it will become 2/3 will become 3/2, and after that, the sign will change to multiplication. Once we're done with the inversion or inverting our our divisor, we are going to change the division sign into a multiplication sign. So it's stated here, multiply the numerators and denominators. So that's 4 times 3, 12, 5 times 2, 10. And we simplify the fraction if necessary. So from 12 over 10, it is an improper fraction. So we convert it to a mixed number. 12 over 10 is just equal to 1 and 1/5. Okay? Wait a minute. I think there's something wrong with this one. So it's not gonna be 1. It's gonna be 2/5. Wait a minute. 1 and 12 divided by 10 is 1 and 2 over, okay, so that's actually correct. 1 and 1/5, because they reduce the value 2 over 10, so it's reduced to 1/5. So this is the correct answer for that. Now we have here steps to consider. So let's discuss it one by one. Change the mixed number to an improper fraction. As always, take note for that. Change the division sign to multiplication sign. And after that, get the reciprocal of the divisor by interchanging its numerator and denominator. So it simply means interchanging. So for example, 2/3 interchanged for that will be 3/2. Okay, 1/2 interchanged for that will be 2. So that's the process of reciprocation, or finding the reciprocal. And after that, if possible, cross cancel. Okay, cross cancel is optional. If you're not familiar with cross cancel, you can do with the multiplication directly. Okay, even me, I do not advise cross canceling, because sometimes you might be confused by your cross cancellation. So for you to have a safe answer, go directly with multiplication. But if you are very confident with cross canceling, then it's not a problem for me. You could do that. After that, convert the results, if improper, to a mixed number. And lastly, reduce your answer in its simplest term. Let's have now example 1.8. Your inventory shows that your warehouse has 15.5 meters of a certain fabric. You instructed your worker to cut the fabric into pieces of 1 and 1/4 meters each. How many pieces of 1 and 1/4 meters fabric would you have? So basically, in this problem, we are just simply going to look at these variables and then divide 1 and 1/4 to 15 and 1/2. So we're gonna use division. Okay, let's write it here in our solution part. 15 and 1/2 is divided by 1 and 1/4. First things first, we convert them, okay? Convert. Convert to improper fraction. Okay, so we convert that one by one. 2 times 15, 30. So this is 31 over 2 divided by 5. 4 times 1. Okay, 5 over 4. And after that, we are going to apply get the reciprocal. The reciprocal of the divisor and change to multiplication sign. or multiplication symbol. This is symbol. Okay, in that case, that's 31 over 2 times 4 over 5. And then we solve that. That's equal to 31 times 4, that is 125. 2 times 5, that is 10. And then we are going to express our improper fraction into a mixed number. But let us look at first 125 over 10. Can we reduce that one? The answer there is 125 over 10 can be reduced to, or can be reduced by, I think it's by 5. I know, by 2. Wait a minute. Reduce it by 2. Yes, we can reduce it by 2. Wait a minute. I got the wrong number, so it should be 4 here. That's my bad. 1, 2, 4. And as we reduce that one, that's equal to 62 over 5, because reducible by 2, or the mixed number is 12 and 2 over 5 for the answer. Fabrics. Okay, so that's our answer. Yeah, I'm so sorry for my handwriting. Okay, so in that case, that's actually 124, not 125. Okay. Now we move on to a conversion of from fractions to decimal to percentage in our next topic. So that's it for the first part of fractions, decimals, and percentage. If you have further questions, please comment down, or you could chat me personally or email me through my Gmail.